Hello, welcome to quiz 6 on calibration. So here we've got a data set, and I walk you through question by question and ask you to calculate each of the expected values that you need in order to construct the solution, right? So you've got to figure out how to figure out these coefficients, right, from these expected values. Not procedurally, it's really easy, but there's just lots of errors, lots of room for little errors, right? And so let's walk through it and make sure we all, if something went wrong, let's understand where it went wrong, right? All right, so the first question is, what's the expected value of y? Not bad. You just have to take the average here. So if I click over to my disembodied terminal here and my piece of paper, I can bring up Python. All right, so the expected value for y, right? So just to review, remember the expected value for y is the sum of all y's divided by the number of samples, right? So in this case, it's going to be, click, let's see, I've got the data in front of me. 8.4 plus 7.1 plus 6.1 plus 4.9. Whoops, 4.9. There we go. That's more like it. And then we need to divide by 4 to find the average. All right. So the answer is 6.625. Good. All right, we've got that. Next, let's see, which was next in our quiz? Click. All right. As I scroll down my quiz, I need to find the expected values of x squared, x to the fourth, and x. Let me go ahead and copy these down so I don't have to keep clicking back and forth. X squared y, and then I'll be done. Okay, so click. There we go. So those are my unknowns. As I scroll back up. All right. Now for x squared, I'm going to need to calculate a separate column, right? Usually we do this as a separate column. I'm going to just write it out here. You can do this really any way you want. But we need to 0.2 squared. Well, most of this we can do in our head. So that's 0.2 squared is 0.04. 1.6 squared, let's see, what's 16 squared? I should know that. 16 squared, that's 2 to the 4th. Squared is going to be 2 to the 8th, which is 256. Excellent, so that's 2.56 plus 2.9. I'm afraid I can't come up with 29 squared off the top of my head, so I'm going to have to actually calculate that out. Oh dear. That's 8.41. And 4.1. I bet I could come up with that if I tried. Yeah, 16 point. Yeah, sure. Should have been able to come up with that. 16.81. There we go. So now we just need to add that all up, and we've got it. So 0.04. All right. Seems reasonable. Divided by 4. That's 6.955. Notice I'm carrying all my sig figs out. If we get sloppy with rounding in this, it has real consequences at the end, so you want to be really careful with your sig figs. Okay. Now we need x to the fourth. So instead of calculating x to the fourth again, well, I guess it's not that hard. So yeah, let's just do x to the fourth now. So 0.2 to the fourth power, yeah, should 0.0016, and oh, I should have known that. Yeah, that's 2 to the 16th. 65,536 is 2 to the 16th power. Why? Everybody knows that. Whoop, silly. There we go. 70. So this is mostly just tedious. But you had to do it, and so do I. Okay. Let's go ahead and sum that up while I've got it. Hmm. 5536 plus 70.7281 plus 282.576. All right, and all of that is divided by 4. We end up with 89.965. Okay. Now, this term here. So to save a little time, I'm not... you could just, if you had this in Excel, you could just multiply this by y. The easier way would have been to use arrays in Python, but I suppose it makes sense for me to go ahead and manually work this out. Okay, so I need to calculate y times x squared. You know what? Yeah. Why not show off Python? Sure, let's do it. I'm not going to manually do this. Let's do it the way I would really do it. So here's my data. So you can do it manually, or I can define arrays. Alright, so now I've got an array defined for x and y, and rather than actually manually calculate this out, I can just do this. There we go. That's a lot easier. Yeah, forget this. So much easier. Just enter the data once, and then you can just do any weird calculation you want without having to make rows or columns in Excel or any bizarre crap like that. All right, am I done? I'm done. All right, good, great. All right, so I'm gonna make a new variable called x2. So here's the way I would have done this. So this is the expected value of x squared. Yep, 6.95. x4. By the way, in Excel, or excuse me, in Python, exponents is a double asterisk. It's like multiply, multiply. That's actually a throwback to Fortran. So if you go way back to the Fortran programming language, that's the way Fortran did exponents too. All right, so x4. Yep, and that's what we got. So we're good to go. Now I'm ready to, I've got all my terms. Now I'm ready to, whoops, click, click. There we go. There's the screen I want. So I've found all my answers here. Now I'm ready to solve for these coefficients. So first it's asking me to solve for A1. I'm going to end up solving for both of them at once. Okay, so now let's go back to my work here. The formula we're given is this. Cool. And we just need to solve for A0 and A2. There is no A1. Mind-bending. All right, so first let's just eliminate A0 algebraically. There are lots of different ways we could do that. In the past, I've done substitution. Why don't I do it a different way this time? So if I just multiply, let's do it with row elimination. If I just multiply this whole equation by x squared and then subtract it from this equation, here's what we'll end up with. So I'm going to subtract it by this times x squared. Expected value, x squared rather. All right, this term will cancel, so I don't even need to bother with it, is equal to A2. All Alright, so I'm going to leave this alone. This was already there. Then I'm going to subtract it by this times expected value of x squared. There we go. So, if I solve for a2, I have here we go. So I can go ahead and figure that out if I just use, again, handy dandy Python now that I have a formula. Let's see. Oh, did I come up with a, let's see, yx2. Let's see. There. So yx2, and then there. So now I've got a value for y. All right, so I want the expected value for yx squared minus expected value for y times expected value for x squared. So I'm just going to enter this in Python. You could do this with a calculator too. I'm just showing you how I'm doing it in Python. And now I've got my, so I'm going to enter my formula all at once, right? So what I've just entered is the expected value for yx squared minus the expected value for y times the expected value for x squared. You'll see that's my numerator. And then in the denominator, I've got the expected value of x to the fourth minus the expected value of x squared squared. The answer is negative, nifty, negative 0.193. We're going to call it. Cool. All right, a naught then is easier. That's just the expected value for y minus the expected a times the expected value for x squared. Okay. Create a variable for a2. There it is. All right, so a naught is my expected value for y minus a2 times expected value for x squared. And we're done. That's it. I've got all my coefficients. All right, I hope that was helpful. Thanks for watching.